Our Sun. It's the giver of life, a constant, blazing presence in our sky that has anchored our world for its entire existence. It feels permanent, eternal. But it's not. Our Sun is about 4.6 billion years old, and like many in middle age, it's headed for a crisis. This isn't about buying a fast car, though, it's about the end of the solar system as we know it. The clock is ticking, not in years, but in billions of years, counting down to the moment our star's midlife crisis becomes a full-blown catastrophe. And scientists have a remarkably clear picture of exactly what's coming. To understand the Sun's spectacular and terrifying future, we first have to understand how it works right now. The stable, middle-aged star right now, the Sun is in the most stable phase of its life, the main sequence. You can think of it as a cosmic adult with a steady job. It's a G-type main sequence star, or as we like to call it, a yellow dwarf. For the last 4.6 billion years, it's been doing the same miraculous thing, day in and day out. Deep inside its core, where temperatures hit a staggering 15 million degrees Celsius, it's running a constant nuclear fusion reactor. The pressure is so intense that it forces hydrogen atoms to smash together and create helium. This process unleashes an incredible amount of energy. This outward push of energy is in a perfect, delicate dance with the inward crush of the Sun's own gravity. This balance is what keeps our star stable, and it has kept the Earth in the habitable zone, that sweet spot with temperatures just right for liquid water and, well, us. But this perfect balance has an expiration date. Every second, the Sun fuses about 600 million tons of hydrogen into helium. It's been doing this for billions of years, but the hydrogen fuel in its core won't last forever. The Sun is slightly less than halfway through its main sequence life, with roughly 5 billion years of fuel left in the tank. Once that fuel starts to get low, the stable, predictable star we know today will begin a transformation that will ultimately tear our solar system apart. The solar birth certificate. So, how can we be so sure about these timelines? How do scientists read a star's birth certificate? Funnily enough, the answer isn't just in the Sun itself, but in the cosmic debris left over from its birth. The story starts about 4.6 billion years ago. There was no Sun, no planets, just a huge, cold cloud of gas and dust called a solar nebula. Something, maybe a shockwave from a nearby exploding star, a supernova, gave this cloud a nudge, causing it to start collapsing under its own gravity. Most of the material, over 99% of it, fell to the center, getting hotter and denser until it roared to life as a protostar, our Sun. The leftovers flattened into a spinning disk around it, which eventually clumped together to form the planets, moons, and asteroids. This means everything in our solar system formed at roughly the same time. To figure out the Sun's age, scientists look for the oldest, most pristine objects they can find, meteorites. These are ancient rocks, leftovers from the solar system's formation that have been floating in space, untouched, for eons. Using a technique called radiometric dating, scientists can measure the decay of radioactive elements inside these meteorites, like uranium turning into lead. This works like a very precise atomic clock. The oldest meteorites all clock in at around 4.57 billion years old, giving us a solid age for our entire solar system and, by extension, the Sun itself. This number is backed up by dating the oldest rocks from the Moon and by running sophisticated models of how stars evolve. The beginning of the end, with about 5 billion years left in its stable phase, the Sun's real crisis is a long way off. But we already know how the story ends. As the Sun uses up the hydrogen in its core, the star's engine room will start to sputter. The delicate dance between gravity and fusion pressure will end. Gravity will win. The core, now packed with inert helium ash, will start to collapse under its own weight. This collapse will paradoxically make the core even hotter and denser. The heat will become so intense that it will ignite a shell of hydrogen that surrounds the now dead core. Imagine a fire running out of logs in the middle, only to start burning the wood piled up around the fireplace instead. This shell burning will actually pump out way more energy than the core burning ever did. This surge of energy will shove the Sun's outer layers outward, causing it to slowly expand and get brighter. Over the next billion to billion and a half years, this will have catastrophic consequences for Earth. Even though the Sun won't be a red giant yet, its increasing brightness will slowly boil our oceans away, turning our blue marble into a dry, scorched rock, totally hostile to life. The very star that once nurtured life on Earth will be the one to extinguish it. The red giant catastrophe. After that long, slow expansion, the Sun will enter its most dramatic phase. It will swell into a true red giant. In a cosmically short amount of time, it will puff up to 200 times its current size. Its outer layers, now stretched thin, will cool, giving the star a deep, menacing red color. The scale of this is just mind-boggling. The bloated sun will easily swallow its closest neighbors, Mercury and Venus. Earth's fate is a bit more of a cliffhanger. For a long time, scientists thought Earth would be vaporized, too. However, there's an ongoing debate. As the sun expands, it will also lose a lot of its mass through powerful solar winds. This would weaken its gravity, possibly letting Earth's orbit drift outward and escape being engulfed. But even if our planet isn't swallowed, it's a hollow victory. The surface will be a molten wasteland, orbiting inside the fiery, thin atmosphere of its dying star. While the inner solar system faces annihilation, the outer solar system will experience a strange, temporary spring. The habitable zone will shift outward, and the frozen moons of Jupiter and Saturn could melt, maybe even forming vast liquid water oceans. Farther out, in the Kuiper belt where Pluto lies, temperatures will get much warmer, possibly even climbing above freezing for a few 100 million years. But this new warmth will be fleeting, a temporary thaw before the sun's final act. The final act and a ghostly remnant after a few 100 million years as a red giant, the sun's core will finally get hot enough, about 100 million degrees, to ignite its helium. In a violent event called a helium flash, it will furiously start fusing that helium into carbon and oxygen. This new fuel gives it a temporary reprieve, causing it to shrink and stabilize for a bit. But helium is a much less efficient fuel than hydrogen, and it will burn through it in a mere 100 million years or so. When the helium runs out, the sun will expand one last time, becoming even larger and more unstable. In a series of powerful thermal pulses, it will shrug off its outer layers, puffing them out into space in a magnificent, glowing shroud of gas and dust. This beautiful, expanding cloud is what astronomers call a planetary nebula. It will glow for a few thousand years, a final, ghostly tribute to the star that once was, before fading into the vastness of space. Left behind at the center of this cosmic ghost will be the sun's exposed core, a white dwarf. This stellar remnant is incredibly weird. It will contain about half the sun's original mass, but crushed into a sphere roughly the size of Earth. A single teaspoon of its material would weigh as much as an elephant. It won't be producing any new heat from fusion. Instead, it will be like a white-hot coal pulled from a fire, glowing with leftover heat at a temperature of over 100,000 degrees. This tiny, dense white dwarf is the sun's final form. It will spend trillions of years slowly cooling and fading, an impossibly long goodbye. Eventually, after a stretch of time far, far longer than the current age of the universe, it will radiate away all its remaining heat and become a cold, dark, invisible object known as a black dwarf, a true stellar corpse. Right now, the universe isn't old enough for any black dwarfs to exist, they remain purely theoretical. From a stable yellow dwarf to a world-destroying red giant, and finally to a ghostly nebula leaving behind a fading white dwarf, that is the ultimate fate of our sun. It's a story of cosmic birth, life, and death that plays out over billions of years. It really puts our own existence into perspective, a fleeting but beautiful moment in the life of a single, ordinary star. If you enjoyed this journey to the end of our solar system, make sure to like and subscribe for more adventures into the cosmos. And let me know in the comments, what other cosmic mysteries are you curious about?